Alright, you guys, please turn to Unit 8, Applications of Trigonometric Functions. Two acute angles are called complementary if their sum is a right angle, or if they add up to 90 degrees. Because the sum of the angles of any triangle is 180 degrees, it follows that, for a right triangle, the two acute angles have to be complementary. The functions sine and cosine, tangent and cotangent, and cosecant and secant are called cofunctions of each other. The cofunctions of any complementary angles are equal. So for example, sine of 30 degrees is going to equal cosine of 60 degrees. If you guys remember from geometry, to solve a right triangle means to find all sides and angles of that triangle. The law of sines and the law of cosines can be used to solve different kinds of triangles. I've drawn a little diagram here, triangle ABC. This diagram, all the variables and stuff actually applies to pretty much the law of sines, law of cosines, this row here, and even the row down here. So anytime you see an A, B, or C, capital or lowercase, just refer to this diagram here. Okay? So go ahead and copy these down. We're going to do some problems in class involving those formulas. I'm going to skip down here for a second. Depending on what information you're given about a triangle, you're going to want to use either the law of sines or law of cosines. AAS, if you guys remember from geometry, this means you're given two angles and a side not in between those two angles. ASA means you're given two angles and the included side. SAS means you're given two sides and the included angle. And SSS means you're given all three sides. Now, SSA is called the ambiguous case because there are different possibilities depending on the conditions that you're given. If your A term is less than h is the height, and h equals b times sine of A, then no triangle is possible because A is going to be too short to reach the base. If A equals h, then you have one right triangle. If A is bigger than h, then it's going to be either this way or this way, one or the other. So if it's like this, you're going to have an acute triangle. If it's like this, you're going to have an obtuse triangle. And if A is greater than or equal to B, you have one triangle. Okay? Here I've given you guys a series of formulas that can be used to find the area of a triangle. This is the one you guys are probably most familiar with, 1/2 base times height. I used a K instead of a capital A because I labeled capital A something else in the diagram up here. I won't scroll all the way up. Okay, and these are some new equations. Where's my cursor? There it is. These are some new equations. Okay, and once again, the A, B's, and C's all apply to that diagram at the top. Heron's formula, the S in this formula is 1/2 times A plus B plus C. So, depending on what information you're given about a triangle, you can decide which formula would be the best to use. An object that moves on a coordinate axis so that the distance d from its rest position at time t is given by one of these equations, where a and w, both bigger than 0, are constants, moves with simple harmonic motion. The motion has an amplitude of a and a period 2 pi over w, just like the equations we learned before. Okay? The frequency of an object in simple harmonic motion is the number of oscillations. Oscillations is when it goes up and down like that. Is the number of oscillations per unit time. Since the period is the time required for one oscillation, it follows that the frequency is basically just the reciprocal of the period. Okay? And w has to be greater than 0, once again. The displacement d of an oscillating object from its at-rest position at time t is given by this equation, where b is the damping factor, or sometimes it's called the damping coefficient, and m is the mass of the oscillating object. Here, A is the displacement at time equals 0, and once again the period is 2 pi over w. This also applies to the simple harmonic motion over here. And that's it for unit 8.